I was mute. Okay, sorry guys, I was mute. Yeah, so I was saying that let's play one Kahoot. Okay, till everyone join. Let's play Kahoot, right? Yeah, Wes. Now it's audible, right? Okay. Right, ready for Kahoot? One small Kahoot till everyone join. Okay. Everyone please join. Right? Okay, very good. Yes, remain same. Easy question, guys. Right, the answer is OD. The answer is OD, right, everyone? See, because it is stress by strain. Now, in last problem, when you said OA, it was this was stress and this was strain, right? So that's why the slope was 1 by y. But in this case, it is stress and this is strain. So slope is y only, right? So most of you made this mistake. Got it? That's why most of you are wrong in this. Let's see the podium, everyone. Aryan, third, very good. Second, Meet, very good, Meet. First, which is Abhiram. Fourth, Pradyumna or Pradyuman. Fifth, Samya. Okay, sorry, Samya. Okay, everyone, right? I hope all of you have. I hope all of you have at least gone through the problem. Tell me, at least gone through the problem, even if you haven't solved, right, or couldn't solve. I expect that all of you have read the problem once. Yes? Okay, Sania? Okay. So all of you can see the screen, right, everyone? All of you can see the screen? Shall we start? Okay. Yes. So we will start with pre-reading. Okay. So what is the answer of question number 1? Tell me. Answer of question number 1. Easy questions. A body which completely regains its original dimension when the deforming forces are removed is said to be. Tell me. Easy. What's the answer of question number 1, everyone? Tell me. Yes, Simba. Very good, right? By definition, it is perfectly elastic. Very good. Second one. Second one. Basic. Very easy. Tell me. Second one. What's the answer? Everyone should solve. Step by step. Mass is given, length is given, cross-section area is given, right? You have to find the stress. Basic formula putting getting. So see here it is mass, right? So what is the formula for stress? Anyone? It should not take this much time, guys. This is quite easy question, formula putting getting. Yes. So force is, I can say that the force is given by what? Tell me. Force is given by mass into acceleration, which is acceleration due to gravity, right, everyone? Tell me, right? Okay. And we know that stress, when we talk about stress, what is the definition of stress? Stress is force per unit area. Now, area is also given. So this is useless information. Okay. Right? Got it? Okay. Next. Third one. Tell me, guys. Third one. Third one. Stress strain curve is there. The region in which Hooke's law holds true. So we know that Hooke's law holds true in which region? Tell me. This is yes, very good, Akshay. Very good, Soumya. This is OA. Very good, right? Easy. Very good. Now fourth one. Fourth one. Very good, Vivek. In the above graph, the point B refers to, now in the same graph, right? This graph, point B is which point? Tell me. We have studied this. Point B. See, this is point B, right? Okay. So this is called as breaking point, limiting point, yield point, none of the above. Tell me. Yes. Very good. Yes, it is. Yes. Elastic limit. Yes, elastic limit is the second name of yield point. Okay, in this case, right? So it is Either elastic limit or yield point. Okay, because elastic limit is not given, right? Next, fifth one, D. So I'll just show you the D. D is easy. D is, tell me guys. Yes, very good, Vivek, very good, Akshaya. Breaking point, right? It's easy. Now, sixth one. The steel wire of length 10 meter and diameter 5 mm. Length is given, diameter is given, stress Young modulus is given. So you have to find delta L, right? Formula putting getting. Yes. Force per unit area is Y into delta L by L. Now, force is given, area is given, delta L you have to find, Y is given, L is given. Can you find delta L? Formula putting getting. Right, everyone? Yes. Okay. Tell me. Okay. Now, seventh one. Now, if you see question number 7th, right? Tell me, guys, seventh one. Same concept, same as question number 6. Don't you think? Same as question number 6, right? So I hope all of you can solve question number 7th also. Very good. Next, in class exercise, question number 1. Okay, question number 1. Now let's see question number 1, everyone. So what do we have here? We have copper wire of length 5 meter. Okay, length is given, suspended from a ceiling. When mass is hanged from its lower end, its length increased by 2 centimeter. Right? Longitudinal strain. Formula putting getting. Tell me, yes or no? Strain is delta L by L. Formula putting getting. Agree? Right? The only thing is it should be in same unit. That's it. So it is 2 into 10 minus 10 by 5. Okay? Easy. First one. Now second one. Think about it. Second one. Go through the problem. We have a solid cylinder, right? Cylindrical steel column of 4 meter length. Okay, this length given, diameter, area given. Decrease in length when the carrying load is this. Now, in this case, again, it is same. Yes or no? Right? Tell me. Stress is given, length is given, area is given, Young modulus is given. Can you find delta L? Same as pre-reading question number 7. Agree? So this, I hope all of you can solve. Easy, right? Just raise your hand, guys. Question number 2, easy. Can you solve it? Think about it. Very good. Very good, Aryan. Samya, Aksha, very good. Right? All of you can solve it. Very good. Next, question number 3. See, basically, this module, right? Module is not difficult. It consists of like quite good questions. Okay. And see, if you have to solve less question, but you have to improve the concept, then module is good. Now, third one, the radius of copper wire is given. Okay. Very good, Abhiram. Radius is given. Think about it. Radius is given. Okay. What force is required to stretch the wire by 20% by its length? Now, delta L by L is also given. This is strain, right? Delta L by L, 20%, which is delta L by L. Elastic limit is not exceeded. Y is also given, right? Area is also given. Same formula putting getting, right? You have to find F. So F is equal to Y into delta L by L into A. Got it? Right? So conceptually, question 1, 2, 3 is your formula putting getting. No, it is steel column, na? Right? It is steel column. So it's like this. It is like this. Okay. Like this. Got it, OS? It is like pillar. Okay. Okay. So level 1 easy. Tell me, level 1 was easy, quite easy. Okay. Now, question number 4, everyone. Question number 4. Think about it. Question number 4. A wire of length L and radius R. Now, think of 4. Everyone, question number 4. Don't you think that this is basic? Yes, we have already derived this. Question number 4, we have already derived this. I hope all of you remember, right? Okay. Okay. Now, do I need to derive question number 4 again? This is the same one that we have derived. If you remember, like this. This one, same concept, right? Okay. So we took elemental area, we calculated, right, delta L in terms of this mass. Mass we wrote as dm, right? Dm we wrote as lambda into dx, right? Then we integrated this, we took as x. I hope all of you remember, right, everyone? Tell me, all of you remember this? So we got what, right? We got, tell me, everything would be same, right? Instead of 1, we will get 2. That's it, right? So normally whatever we got, we will get 2 because of this integration of x. Okay, right? Yes, I hope all of you remember this. So 4th one we already did. 5th one, let's try solving 5th one. Think about it, guys. This diagram is for 4th one, if you remember. Now 5th one is good problem. Okay. Yes, Abhiram, we will see. Now 5th one, think about it, everyone. Think about it. A light rod of length 200 centimeters suspended from ceiling horizontally by means of 2 vertical wires. Okay, right? One of the wires made of steel and its cross section. Okay, okay, okay. Equal stress in both wire, equal strains both wire. Okay. Now let's try to solve this. Everyone, just go through the problem. I'll just take the snapshot. Okay, very good, Abhiram. So let's see. Let's see, everyone. Now, in this case, what is given? Right? Just try to think what is given. A rod of length 200 centimeters suspended from ceiling. Okay, so we have a ceiling like this. Then a rod is suspended. So suppose this is a rod. Okay, this is a rod, and this is suspended. This is first wire, and this is second wire, right? Because it is suspended by 2 wires, right? This is of steel, and this is of brass. Cross section is given. Along the rod, at what distance a weight should be produced? Wait, everyone. Okay, sorry. Okay, so yeah, the question is at what distance the weight should be hung to produce equal stress and an equal strain. So let's solve question number 1 first. First, equal stress. What's the meaning of equal stress? Tell me. Equal stress means the ratio of, let's suppose we hang it at this distance, right? We hang this weight at this distance, okay, right? The total length, I'm supposing that total length between two wires is given. Yes, very good, Abhiram, very good. So stress are equal. So I'll just say that stress in wire A, this is wire A and this is wire B. Stress in A is equal to stress in B, right? So what's the formula for stress? So stress is because of this force tension. So it is tension in A by area of A is equal to tension in B by area of B, right everyone? Tell me, right? Okay. Now, when we talk about tension, how to find tension? Tell me how to find tension. So first we will have a force balance equation. If you see this, so this is tension in A and this is tension in B. So can I say that first equation is TA plus TB is equal to this W mass W, agree, right? Okay. Now second case, right? Because we have two unknown, so should have two variable. Now suppose this is distance X, this is distance X, right? And the total length is L. So this distance is L minus X. This distance is L minus X. X and L minus X. Agree? So I can say that around this point, torque due to this and torque due to this are equal, right? Yes, Karishma, you can take T1, T2, doesn't matter. Okay. Think about it. Yes or no? Yes. So we will write the torque equation. So what is the torque due to this force? Tell me, what is the torque due to this force? Voice is breaking. No, Karishma, I don't think the voice would break. Okay. So yeah. So when we talk about, yes, so when we talk about torque equation, it is TA into X, or I'll just write T1 into X is equal to, right, is equal to this, which is TB or T2 into L minus X. Okay, right? Got it? Got it, everyone? Think about it. Yes or no? So we have two variable. Okay, so can we solve for these two? Right? This is first equation, the second equation. So we will put and solve for each other. Okay, now after solving, what we need? We just need this value, right? We just need X, right? First, if we get X, then we can find TA and TB, because we just need X. Got it? Okay, so from here, we already know, right? T1 is A1 by A2 into T2. So we'll use this equation, we'll put it over here. Then from here, we can find the value of X. I hope all of you can understood this question one. Yes? Tell me. Yes, got it? First one, everyone just raise your hand. If you got first one, just raise your hand. Okay, next, second one. So if we have equal strain, right? If you have equal strain, we will do the same thing. Now for equal strain, I can say that, right? E1 is equal to epsilon 1 is equal to epsilon 2. Okay, right? And we already calculated the ratio of stress, which is sigma 1 and sigma 2. Okay, so can I say that, okay, this is E1 is what? Because Y, right? It is sigma 1 by Y1 is equal to sigma 2 by Y2. Agree, everyone? Agree? Yes. Yes, Abhiram. Which is T1 by A1 into Y1 is equal to T2 by A2 into Y2. So in this case, right, see, A1 given, A2 given, Y1 given, Y2 given, we will put it, can we find the relationship between T1 and T2, right? And then again, use this relationship, okay? Got it? Tell me everyone, got it? Yes, so Abhiram is saying T1 will be equal to T2, T1 will equal to T2, right? Then we will use these equations. Okay, very good. Next. So question number 5th. Now 5th was good and easy question, not as easy, but it was good question, right? So 6th one, let's see question number 6. A copper wire of unit mass, 1 meter length and cross section area. Okay, length is given, cross section is given. Is kept on a smooth horizontal table with one end fixed. Okay, the ball of mass 1 kg is stretched to the other end. Okay, the wire rotating. Okay, now if you remember, this is the, tell me, this is the case of rotation, right? So we have solved a problem like this. If you remember, we have solved a problem like this. Tell me yes or no. Right? So the only difference here is, instead of tension is equal to mg, yes, Abhiram, very good. We'll have tension is equal to, tell me, m omega square r. Yes or no? Tell me guys, yes or no? Right? Now, let's write down the information that we have. Length we have, right? Cross section area we have already. Mass we have already. Then omega we have already. Delta L we have already. Obtain the Young modulus. Formula putting getting, don't you think? Right? First one, formula putting getting. Yes or no? Tell me. Young modulus is equal to stress by strain. Stress is equal to what? Force per unit area into delta L by L. F is given, L is given, A is given, delta L is given. F is equal to what? This m omega square r. Put it, you will get the answer. Anyone have any issues? Tell me. Anyone have any issues in this? First one? No? Formula putting getting? Think about it. Yes? Raise your hand everyone if you understood the first portion, right? It was easy. Formula putting getting, we have already solved, right? Okay, next one. When you talk about the second one, think about it. If increasing the velocity to 180 per second, the another wire breaks down. Obtain is breaking stress. Easy, right? Instead of using omega as this, use omega as this, right? As simple as that. Got it, right? And stress is what? Tension by area, which is m omega dash squared into r by area. Okay, easy. 7th one. Okay, guys. Now let's see question number 8. Sorry, 7, not 8, 7 first. Right? 7. The length of metal wire is L1 when the tension is T1 and is L2 when tension is T2. What is the natural length of the wire? Now, don't you think that you can solve it? Tell me. Don't you think that you can solve it? What is constant? Tell me, what is constant? Yes. What is constant here? Think about it. What is constant here? If material is constant, right, which parameter will be constant? Think about it. Young modulus will be constant, na? Right? Yes. So Young modulus, yes, very good, Abhiram. So it will be what? Stress 1, right? Stress 1 by strain 1. In first case, okay. Suppose natural length is L. Suppose natural length is L. So can I say that Y is equal to, in first case, right? Suppose tension is T1. T1 and area will also be constant, right? So T1 by, tell me, A into delta L. Delta L what? L1 minus L into L, original length, right? And since it is constant, it should be equal to, it should be, wait, what happened? Okay, it should be equal to what? T2 by A, area will be constant, into L2 minus L into L. Think about it, yes or no? Yes or no? Now T2 is given, area constant, L you have to find, equate these two and solve. You will get the answer. Yes or no? Tell me guys, will you get this? So it is T1 into L by A into L1 minus L is equal to T2 into L by A into L2 minus L, right? AA get cancelled. This LL get cancelled. Cross multiply and solve. It will be easy. Right, everyone? Okay. Seventh one. Think about it. Was it very difficult problem? Just think about it. 1 to 7. Do you think that these are very difficult problems that you couldn't solve? Okay. Question number 8, right? 8. Last question of this. Now figure is given. Think about it. Figure is given. Now see how easy this question is, right? If you know the concept, how easy this question is. Yeah, it should be A because of this, right? But if friction is not there, right, then, okay, let's see first, right? Let's see first. Here, it is A. It is A, right? It is print, I guess. We will take it as A, okay, right? So when we talk about the free body diagram, mg in downward direction, tension upward direction, right? First equation on this object will be mg minus tension or T1. T1 is equal to MA. Okay, Abhiram, tell me, everyone, think about it. Yes or no? Think about it, guys. Yes or no? Yes? Simple. Okay. Now, on Q, on this Q, we will have T1 in this side, right? T2 this side. So let us assume T1 is greater than T2. So T1 minus T2 is equal to M2A. Constraint relationship, I hope all of you know that since all of them are in constraint relationship, the acceleration will be same. Okay. Yes. And third is T2 is equal to M3A. Got it, right? Okay. Now, it is also given that mass are equal. Mass are equal. Yes or no? Mass is equal. So put T1 over here, right? T2 over here. You will get T1. If you put T2 over here, we will get T1 is equal to what? T1 is equal to 2 MA. Agree, right? Because M2, M3, M1 equal. Now put T1 over here. If you put T1 over here, we will get Mg is equal to 3 MA, right? So A is equal to G by 3. Expression is G by 3. Easy? Think about it. Easy? Right? So if you get acceleration, right? If you get acceleration, then T1 is equal to what? Tell me. T1 is 2 mg by 3 and T2 is equal to, tell me. T2 is equal to mg by 3. Anyone have any issue in this? Anyone have any issue in this? Raise your hand. Right? Now, can you solve longitudinal strain in each wire? Because you just have to get T and TB now. I hope now you can find the longitudinal strain, right? Because tension is calculated, right? Got it, everyone? Just raise your hand. If you got this, just raise your hand. Okay, very good, everyone. So I hope all of you got the concept of stress, longitudinal stress and longitudinal strain, right? So 9.1 we calculated. Okay, I hope all of you understood this. If not, you can just watch the video once again. Okay, right? Homework you can do till question number 10. Okay, homework you can do till question number 10. Okay, till question number 10 you can solve homework. Now 9.2, let's see 9.2. See, question number 11, 12, 13, 14 are quite good question. Okay, 13 everyone can try. 13 is not that difficult. Okay, 13 everyone can try, right? 11 is very good problem. When you talk about 11, it is a good problem, right? So those who are like obviously advanced students should solve all, but 13 everyone can try. 13 everyone can try. Okay, homework 13 everyone can try. Now 9.2, pre-reading. Very good, Abhiram. You guys have to do level 3. Okay, it's not option for you guys. It's for NEET students and those who are not preparing, like not solving very difficult problem for now. Okay, first one, tell me, on stretching a wire, the elastic energy stored per unit volume is, tell me everyone. Easy, tell me guys. It was easy. What's the answer of question number 1? Okay, it's tell me. A, yes, half into stress into strain. Very good. Second one, try to solve everyone, try to solve. The compressibility of water is given, right? Compressibility is given. What's the meaning of compressibility? Tell me. I hope all of you remember compressibility is K, right? And bulk modulus is 1 by K. Yes or no? How many of you remember this, guys? How many of you remember this? Right? And just see the unit, per unit ATM, right? So B is 1 by K. Now, B you can calculate if compressibility is given, delta V is given, right? Okay. Sorry, delta V you have to find. Okay, just have to find delta V. So we know that P is equal to B into delta V by V. P given, beta, sorry, B we calculated, V given, delta V you can find, formula putting getting, right? Okay. Okay. Next is question number 3. A 5 centimeter cube of substance has upper surface displaced by this. Okay. Now, don't you think that this is easy? Modulus rigidity, formula putting getting, right? Formula putting getting. Think about it. We know that, right? Modulus of rigidity is again tangential, stress, right? Or shear stress by shear strain. Got it? Now, I can say that 5 centimeters, 0.65 centimeter. The ratio is very less. Yes or no? The ratio is very less, right? So if ratio is less, I can just, right? I can just take theta instead of tan theta. Yes or no? Tell me, yes or no? Tan theta is equal to, or you just take tan theta, doesn't matter. Okay, is equal to what? Change in this, which is 0.65 by this 5. This is tan theta, right? Which is your shear strain. Okay, and force is 0.25 by area, which is 5 square, 25 centimeters square. So in meter, right? In meter, you have to multiply by 10 minus 4. Got it? Right? So I hope all of you can solve it. Just take the ratio. Okay. Right? Third one easy. Now, level 1, question number 1 to 4. Think about it, guys. First one, okay, first one, formula putting getting. I hope all of you can solve it. Just raise your hand. First one, all of you can solve. Yes or no? Raise your hand, everyone. First one you can solve. Okay, very good. Second one also formula putting getting, right? We know that work done is equal to elastic potential energy. Yes or no? Tell me, yes or no? Second one also formula putting getting, all of you can solve. Third one. Third one, tell me. Third one is same as third of pre-reading. Yes or no? Tell me, yes or no? Okay, so third one also formula putting getting. Most of you, I hope all of you can solve. Okay, fourth, let's see question number fourth. Guys, fourth question number. Okay, I'll ask someone, right? I'll ask someone, please let me know how to solve question number fourth. Amish, I'm unmuting you. Amish, please tell me how to solve question number four. Amish, can you hear me? Amish, are you there? Who can solve question number four? Tell me who can solve question number four? Priyanka, can you solve question number four? Ronak can solve, right? Okay, Ronak, tell me how to solve question number four. You can unmute yourself. Tell me, Ronak.
Hello, sir.
Yeah, Ronak. I can hear you. Tell me how to solve question number four.
Sir, we can apply the formula of bulk modulus of rigidity. B is equal to minus delta P upon delta V into V.
Very good. Into V, right? Yes. Okay. Then everything is given. It is formula putting getting, right?
Yes.
Okay. So everyone understood this? Tell me, guys. Okay, thank you, Ronak. Now question number 5. So see, in this bulk model is given. Okay, volume we already have. Delta P we already have. You have to find delta V. Okay. So all of you can calculate delta V. It was formula putting getting, as Ronak said. Next question number 5. Guys, those from now onwards, I'll ask some of you to explain how to solve this. Okay, and everyone needs to explain. Okay, because it is becoming one-sided class and almost half of the class is absent. Okay, next question number 5. Question number 5. Akshay, can you explain question number 5? Or leave question 5 because it is based on torsional strain. Okay, so since I haven't taught torsional strain, question 5 you can leave. Okay, we will solve after studying torsional strain. Question number 6. Akshay, question number 6, can you solve? Anurag? Chulika, can you solve question number 6? Tell me. This is quite easy question, formula putting getting. Who can solve this? Just raise your hand. Except you, Abhiram. Pradyuman, can you explain? Question number 6. Pradyuman, can you hear me, Pradyuman?
Yes, sir.
Yeah, question number 6, can you explain?
Yes, sir. Wait a minute.
Uh-huh. Question number 6, guys. I'll ask each one of you to explain one problem. Okay. This is becoming one-sided class. Try to understand the problem first. Okay, try to understand the problem, everyone. Right? What is given, what is asked, and what you know. Because formulas, when you talk about formulas, we just have the formulas of stress is equal to some constant into strain and then potential energy. That's it, right? We don't have any other formula. And you have to find what? Calculate an increase in energy of a brass bar, right? Length is given, cross-section area is given, when compressed with load is given along its length, right? Young model is also given. So it is just formula putting getting. Yes or no? Tell me. Yes or no? Yes, Abhiram. Very good. Pradyuman? Okay, just think about it. Think about it. What is the formula of elastic energy? Tell me, everyone. Just message. What is the formula of elastic energy? Guys, I request you to actively participate. Okay. What's the formula of elastic energy? Half into stress into strain per volume, right? So half into stress into strain into volume. Yes or no? Half into stress into strain into volume, right? Now, first we have to calculate strain because we can calculate stress. Weight is given, length is given, area is given. So I can calculate strain, yes or no? Strain is equal to stress by Young modulus. Agree? Agree? Very good, right? Yes. Now, after calculating strain, energy is basically half into stress into strain, right? Into area into length, right? Because you have to calculate the energy, not energy per unit volume. Now, don't you think that this was easy? Tell me. Pradyuman, got it? Okay. Yes, it's around 2.4, 2.5. Okay. Right? Easy. Okay, everyone. Next. Question number 7. Sorry, question number 6 done. Question number 7. Think about question number 7. Now, question number 7 is basically the derivation of formula. Yes or no? Tell me. That we have already done. Yes or no? Right? So question number 7 we already did. It is the derivation of formula. Okay? Half into stress into strain. Right? So we already did it. In last class, we derived this formula. I hope all of you remember. Right? We derived this formula. How we derived it? Using work done. Yes? Okay? Okay, right? So 7th also we did. 8th one, Eighth one, calculate the work done in stretching uniform metal wire. Now, see, work done is same as elastic potential energy, yes or no, right? So area is given, length is given, right? Change in length is given, Young modulus is given. Tell me, strain you can calculate, change in length by length, then stress you can calculate, right? Area you have, so half into stress into strain into a volume. Now tell me, think about it. Was that difficult? Guys, tell me, was that difficult? You have to ask yourself, okay, is this really difficult or you haven't practiced enough, right? Because anyways, it's not formality now, right? You have to solve. See, especially 9.2, most of the question of 9.2 was straight away formula putting getting. Okay, right? Think about it. Okay, so let's discuss the problems of this HC Verma. Okay, wait, give me 1 minute. I'll just open up the problem of HC Verma. I don't know, Arjun, it might be that answer. Okay, right? You can just check in the module. Okay, guys, we have HC Verma problems. Yeah, Arjun. So see, we will have two modules because soft copy, this module I'll be uploading, don't worry, right? New modules you can have for extra practice. Okay, got it? And the answer is given at the end of the module anyways, right? So you can have two modules for practice. Okay, because I personally like this module. Okay, now I hope all of you remember the problems that I have given. So see, we have solved these kind of problems, right? If you have gone through this example, right, most of the problems you could have solved. Yes or no? Tell me. Except for the surface area, we haven't, sorry, surface tension, because we haven't studied that topic yet. But apart from that, all of the examples you could have solved. Yes or no? Guys, objective 1, objective 2, you have to solve. We will discuss it someday at once. Okay, now let's discuss this. All of you can see the screen? Yes. Now I gave you question number this fourth one, right? Fourth one. Let's discuss question of 4, everyone. So steel wire and copper wire of equal length and equal. Now this is something, right? Let's think about this. Think about this, everyone. Okay, what is given? Tell me what is given. Steel wire and copper wire, right? Okay, and they're joined end to end. Okay, and subjected to tension. Find the ratio of stress developed in two wires and strain developed in two wires. So start with the basic formula. Tell me, start with the basic formula. When you talk about stress, what is the formula for stress? Tell me, what is the formula for stress? Tension per unit area. Got it? Right? Now it is given that equal length and equal area. So length is equal, area is also equal. So don't you think that the ratio of stress is basically the ratio of force? Yes or no? Think about it. Yes or no? This is quite easy question. You don't have to solve anything, right? So first one is easy, right? And think about it. If they're subjected to common tension, then the forces are equal, right, everyone? Right? So can I say that the stress in both of them will be equal, right? Now, if stress is equal, then the ratio of strain is equal to their Young modulus. Yes, very good, Abhiram. Okay, right? So fifth one easy, fourth one easy, conceptual, right? Now, fifth one also it was easy. You could have solved. After fifth, I have told you to solve question number 6, right? 6. Now let's see question number 6, everyone. Think about it. Okay, now actually we just have to calculate tension. Yes or no? Think about it. Yes or no? Right? Now when you talk about this M1, right? When you talk about this M1, okay, so suppose this is your tension 1, T1, and this is your tension 2, T2. Okay, right, everyone? Tell me, right? And suppose this mass is M. So can I say that T1 is basically, right, M1 plus M into G? Sorry, M1 plus M into G? Yes or no? Think about it. I can take those two as a system. I hope all of you remember this. Okay, easy. Then stress is this by this wire, right? Area of this wire, or A1. Formula putting getting easy or not? Tell me, easy or not? In the same way, right? In the same way, this is stress 1. In the same way for stress 2, right? You will take tension 2, which is total mass M1 plus M2 plus M into G by second. Okay, very good, right? So I hope all of you can solve this. Then after this, I told you to solve which question? Ninth one. Now, don't you think that ninth one you can solve now? Right? Just go through this question number 9, everyone. Isn't it same as the one that we just discussed in module, right? Because see, if you understand the concept, what all you have to do is to calculate tension or to calculate total force, net force, right? And net acceleration. So we have two body, M2 and M1 in question number 9. Okay, and it is given that the F is equal to M2 G by 2. Okay, so let's draw the free body diagram of this one, M2. So okay, if F is in this direction, right? Now let us assume that this is still moving downward because of this mg. So I can write it down like m2g minus t, this tension, is equal to m2a. Agree? Tell me, guys, agree? Right? And on this object, I can say that, okay, I can say that t minus f is equal. Anyone have any issue in this? No? Right? Everyone got this? Just raise your hand, everyone. Now, f is already given. Don't you think that f is already given? So can you calculate t in terms of this? It is m1a plus f. Now put t over here. So m2g minus m1a minus f is equal to m2a, right? So a is equal to what? This will go this side, m2g minus f by m1 plus m2. Agree? Tell me, guys, agree? Right? So once you can find A, you can find tension, and after finding tension, you can find stress or strain. Got it? Tell me, got it? Yes or no? Tell me, guys. Easy? This is same as the one we did in a module. Okay? Okay. Now after this, I gave you question number 10 also. Question number 10. Now, everyone just go through question number 10. Take your time. Right? Question number 10. Sneha, try, write down the name of students who are not present now. And just post in the group itself, main group. The 17 students are absent now. Okay, now read question number 10. See, first of all, if you actually understood the problem, right? So you might be getting how to solve problems, right? You just have to find either force, right? If you see this, right? Any problem that we are solving, either we just have to solve force or we just have to apply formula. Think about it, yes or no? After discussing this much problem, at least we discussed around 15 to 20 problems, including everything, right? 15 problems we have discussed at least, right? In all the problems, we either calculated force or used formula. Yes or no, right? Now, when we think about this problem, sphere of mass 20 kg is suspended by a metal wire of unstretched length 4 meter. It is original length. This is area. So length is given, right? 4 meter. Area is given, okay, 1 meter. Mass is given, okay. Now, when in equilibrium, there is a clear gap of 2 mm between the sphere and the floor, okay, right? The sphere is gently pushed aside so that the wire makes an angle 30 degrees with the vertical. Now, it is actually like this, right? It is like this, okay, and it is pushed, right? So it is making theta now, okay, right? Now find the maximum value of theta so that the sphere does not rub the floor. Now, if you think if it is pushed, right, then I can assume, just try to assume what will happen, right? First of all of you try to assume what will happen. Think about it, guys. If you push it, suppose this will go at this point, right? Suppose if this will go this point, what will be the path of this ball? Tell me, will there be any additional force? Yes, Abhiram, very good. So I can say that delta L max, right, should be 2 mm, right? Tell me, think about it, yes or no? Because it is given that this gap of only 2 mm. Now, how this extra elongation is achieved? Think about it. How this extra elongation is achieved? Which force is responsible for that? Tell me, which force is responsible for that? Very good, Wes. Centrifugal. Yes, very good. And what is the formula for centrifugal force? What is the formula for centrifugal force? mv square by r. Very good. Now we have to find velocity v. Yes or no? Think about it. And if I'm not wrong, all of you have solved this kind of problem in work power energy. Yes or no? Right? Which concept we use to find velocity? Tell me. Which concept we use? I'll just make it bigger. Okay, this is the problem, right? So the problem was like this. Okay. Why can't I draw a straight line? Okay, I hope all of you have already solved this kind of problem, right? So velocity at this point. So which concept is used? Tell me, guys, which concept is used? Okay, Abhiram, I'm not using the formula yet, right? I'm not using the values yet. I'm just trying to use the terms, okay, right? So I can say that what we have, right? Think about it. What we need to calculate? We need to calculate tension, right? Okay, okay, because we are asked to find theta, maximum theta, right? Tension is equal to mv square by r. R is constant, which is the length of the wire, right? Now we know that in order to calculate V, we have to use work energy theorem. Yes or no? Tell me, guys. Yes or no? Okay, right? Now work energy theorem between these 2 points. This is point A, this is point B. I hope all of you have already calculated this. Now at this point, it is just potential, sorry, kinetic energy. At this point, it is just potential energy. So let's calculate. So at point B, we have just kinetic energy is half mv square that we require, right? And at this point, we just have potential energy, and this is height h. What is this height h? This is total length L. So this is mg, total length L minus this length, which is L cos theta. L cos theta. Agree, everyone? Tell me, agree? Yes or no? Anyone have any issues in this? So from here, I can calculate, okay, mv square, right, is equal to 2 mgl bracket 1 minus cos theta, right? So, and this r is actually length only, right? This r is actually length only. So this is mv square by L only, right? So this tension is basically, this tension is equal to what? mv square is this 2 mgl by L into 1 minus cos theta. L will get cancelled. Now, if you get tension, can you use stress? Think about it, right? Can you use this stress T by A is equal to Y delta L by L? Now think about it, right? You have to find theta. You have to find theta. Everything else is given. Can you do that? Tell me, guys, can you do that? Yes or no? Think about it. 2 mg 1 minus cos theta divided by A is equal to Y delta L by L, right? Everything is given, just find cos theta, right? Cos theta is equal to something. Okay, got it? Easy? Okay, right? So this question clear? Okay, next question, which was the next problem? So question number 10, clear, I hope, right? Next was after 10th. After then, which question? Wait, let me check. Okay, after 10th, I have given many problems, 11, 12, 13, 11, 12, I guess, 11th and 11 and so 11 is actually easy, try it. 11 is actually easy, okay, right? Yes, 11 and 12 are actually easy, you can try it. Okay, if you can't solve, then we will discuss, right? Let's discuss question number 14 for now. Okay, 14, right? Let's discuss question 14 for now because we are running out of time. Now, when you talk about question 14, think about it. Estimate the change in density of water in ocean at the depth of 400 meter, right? Below the surface. The density of water at the surface is given. Bulk modulus is given. Now, what do you think? What do you think? What will happen? Think about it. What will change? Will mass change? Right? See how easy this question is. Will mass change? Will mass of water will change? Think about it. Yes or no? No. Volume will change. Yes or yes, right? Because water will exert pressure on itself. So volume will change. Yes or no? Okay. So let's try to calculate this, right? Let's try to calculate this, right? I'll just use the general term. Okay. Now let's try to solve this. So we already know, right? Let's see what we already know. Okay. We know the basic formula of bulk modulus, right? So let's see, delta P is equal to, right? I'm not using the sign, okay? Because again, it will be ignored, right? I just want to find the change. Anyone have any issue in this? Tell me, anyone have any issue in this? Okay, now we know that this delta P is due to rho GH. Yes or no? Tell me, rho GH. Right? So I'll write it as rho GH. Okay, is equal to B. What is delta V? Delta V is, right? I'll just put negative inside, right? Okay, I'll just put it negative over here. I'll put negative inside. So can I say that it is V at the surface? V at the surface minus V at depth? Tell me, yes or no? Divided by V at the surface. This is actually V at depth minus V at surface by V at surface. So I've taken minus inside this. Got it? Anyone have any issue in this? Tell me, anyone have any issue in this? Okay. Yes, Abhiram, you can just derive that formula, because see, right? Beta is equal to, if mass is constant, think about it, if mass is constant, then I can say that, right? Rho at surface is equal to mass by volume at surface. Think about it, right? And rho at depth is equal to mass by volume at depth. Got it? Tell me yes or no, right? So you can take the ratio, rho at surface by rho at depth is equal to volume at, sorry, okay, wait, it will get closed, right? Okay, yeah. Sorry guys, this will get closed. Wait for some minute. I don't know what happened. Okay, yeah. So density at surface, depth is given by velocity at depth by velocity at surface. Yes or no? Tell me, right? Okay, so delta V by V, delta V by V. Okay, you can calculate. Got it, Abhiram? Right? So it's basically the same formula. Okay, it's basically the same formula. Yes or no? Right? So just think about it. It is what? It is 1 minus Vd by Vs. And what is Vd by Vs? It is rho s by rho d. So it can be written as 1 minus rho s by rho d. Got it? Just put it over here, right? And you will get the answer. Yes or no? Tell me, guys. Yes or no? Right? Okay. Got it? Tell me, got it? Okay. Next. Next was question number last 18. Let's solve question number. Okay, question number 18 is again, I guess. Okay, 18 is based on surface tension. Okay, 18 is also based on surface tension, right? So till 17, you could 70 is also surface tension. So you could have solved till question number 15 only, right? Till 15 because 16, 17, 18 are of surface tension. So we are done with this. Okay, we are done with this. Next, we will start surface. See, the thing is, according to our module, surface tension is in fluids. Okay, that's why we haven't studied surface tension, right? So I hope all of you can solve module, right? For now, okay. So next class we will start. We will try to complete this chapter because we are left with only one topic, which is torsional strain. So that will hardly take 15 minutes. After that, we'll start with fluid. Then after that, okay, right? Yes, I'm saying, right? After that, in this week's advanced class, we will discuss the doubts of gravitation. Okay, advanced doubt of gravitation, level 3 question of gravitation. Okay. So those who want to attend, you can attend that. Okay. Right. And one class we will have for all the doubts of solids, right? Okay. Okay. So those who have, yeah, so we will discuss all the problems that you have. If you have any other problems, just message in the chat box, right? WhatsApp group, we'll discuss all the problems. Okay. Okay. Thank you, everyone. Bye, everyone. Bye, everyone. Thank you, everyone.